What's going on, everybody? Mr. Diamond here again, and we're going to be going over our electron configuration notation notes. And you are going to want a periodic table. I've got one that's just like the one that you guys have that I'm going to be referring to throughout this. So if you've got that nearby, go ahead and find that, and I would pull it out. So we're going to be going over our electron configurations, and these are the things that go into place after that metaphor that I left in the notes here. The first one we're going to do is just called electron configuration notation, and this is the idea behind electron. Let me make sure that I'm in frame before I just screw up. Nope. Okay, we're in frame. So the goal of electron configuration notation, otherwise known as ECN, is to write every orbital, including how many electrons are in that orbital, until you have listed them all. So going back to what we had talked about before, let's say, for example, that we wanted to do bromine. And bromine symbol is BR. So if I go to my periodic table and I find bromine, so I'm going to make a little note with my purple pen on this one. So bromine is right there. What we're going to do is we're going to, in order, label every single electron for bromine. Now, if you remember, we have to fill the lower levels first. So really what we're going to do is we're going to start at number 1 on the periodic table, and we're going to list what are these orbitals called and number if they're full or if they're not full until we get all the way through to bromine. So the first things you find on the periodic table, the very first elements, hydrogen and helium, this is in the S block, and it's the first row. So we would call the very first set of electrons 1S. And then because it is full, because we're going to be moving past hydrogen and helium there, it would contain a total of 2 electrons. So the first 2 electrons that are found inside of bromine fill on the 1s energy level. So this is the energy level, this is the orbital type, and this is how many electrons are in that orbital. So after 1s, that's number 1 and then number 2 over here. We're then going to go, here's 3 and 4. So that's on the second S. And it's also got both of them because we're also going to be moving past there. The way I like to describe it is you're just going to keep going and keep counting until you reach whatever element it is you're trying to talk about. So we're going to keep going until we hit bromine. So we've done 2s. 5, 6, 7, 8, 9, 10 are all this next block right here. So if we remember our names of our orbital types, we've got SP, because it's SPDF, SPDF. So we've got this one started on 1, this one's going to start on 2. So this row right here, starting with boron, that would be 2P. And because we're going to be moving all the way through it, we don't need to stop and do anything in that area. We are going to have all 1, 2, 3, 4, 5, 6. So it'll be 2p6. Let me scoot that up a little bit. So now we're here. We're at neon. The next one is back in the S block, but it's the third one. So it's 3s, and we're not stopping on either of these elements. So it's got both of those electrons. And the reason we can make this assumption is because they're always going to go from low to high, and we're numbering them from lowest energy to highest energy. So we always know that these electrons had to be there because they had to fill in that order. So 3s has both of its electrons. Then we're going to come over here. This was 2p, so this one will be 3p, and we're not stopping here. So that's 1, 2, 3, 4, 5, 6, 3p, 6. We're going to come down next is potassium and calcium. So that's 1, 2, 3, 4 S, and we've got both of those. So it's 4S2. Now for 21 to 30, that's in this middle chunk right here. So remember, this was SPD, and then the bottom down here is F. So SPDF, SPDF. And it starts on 1, 2, 3. So even though we just did a 4 and it's on the 4th row, this is actually going to be 3D. And then 3D has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got all 10 of those electrons. Okay, we have now reached, so this was 2, 3, we are on 4P, and 4P, this row right here, is the chunk that has what we're looking for. We are trying to get to bromine. So what we're going to do is we're just going to count over until we get to bromine, and instead of counting 6, because that's how many is in this row, we're going to go 1, 2, 3, 4, 5. So this whole long piece right here is the ECN, the electron configuration notation for bromine. And it would be the whole thing. It's not just this last piece. It's telling you that all of the electrons in bromine, in the 1s level there is 2, in the 2s there is 2, in the 2p there is 6, in the 3s there is 2, in the 3p there is 6, in the 4s there is 2, in the 3d there is 10, in the 4p there is 5 total electrons. Now, one way you can check this, bromine has a Z, or an atomic number, of 35. 5 plus 10 is 15, 16, 17, 23, 24, 25, 31, 32, 33, 34, 35. So the superscripts, or the more normal way of saying it is the exponents, should add to atomic number. All right, so we've got our electron configuration notation for bromine. Now, there is one kind of shortcut you can take, or one extra kind of shortened step that we can do, and that is called the noble gas configuration. And the basic idea is, because noble gases are stable, which you probably learned in your earlier classes, that they're all very, very stable, we can assume that electrons are, and we're going to just say this as acting normal. So instead of labeling the whole thing, instead of labeling all electrons, we start with the closest previous, which means it has to be the closest before. Let me make sure I'm not writing off the page. We start with the closest previous noble gas and begin counting there. Okay, so what does that mean for our example problems? Well, if we do bromine again, let's go back to our table. Bromine is right here. We're going to go to the noble gas, which, remember, this column here is the noble gases, which that's on the screen. Okay. So those are our noble gases. The noble gas that's before it is argon. This is the noble gas that comes closest before it. Think of Price is Right rules, closest without going over. So we are actually, instead of starting with any of the other elemental things, we're going to start with a bracket and then the symbol for argon. And that bracket represents everything leading up to argon, which in the case of this one would be 1s2, 2s2, 2p6, 3s2, 3p6. all of that information, because that is what it would be for argon. You would go 1s2, 2s2, 2p6, 3s2, 3p6. Because argon always behaves the same way because it's a noble gas, we can assume that those are all going to be the same piece of information. And then we just pick up numbering after argon. So starting after argon, going to the next thing, argon was number 18. Number 19 is over here. It's potassium. And that is 1, 2, 3, 4 S2. And you'll notice that we now get to just basically pick up from where that started right here. So it would be 4s2. Then next would be, remember, it's SPDF. 1, 2, 3, 4. So it'll be 3D10. And then it'll be 4P5 because it will be 3D. And this was 2P, 3P, 4P, 1, 2, 3, 4, 5. So that is quite a bit shorter than doing this. And that is how you do a noble gas configuration, and that is how you do an electron configuration notation, or an ECN. You will have to be able to do both of these on the test, along with the other one that I'm going to teach in a separate video because I think it's unique enough and it's more confusing, so it deserves its own video. I hope that makes sense. If you have any questions, feel free to shoot me an email. I saw a yawn at the end of this video. I apologize for that. Shoot me an email. Try to hop into a Zoom. In the meantime, this is Mr. Diamond signing off. I hope you have a great rest of your day.